Hello, my name is Lucas Rug, and this is my presentation on fingerprint detection. Fingerprint detection is commonly used for high-profile criminal cases because it only leads back to the one person. But there are many factors such as surface touch, dirt, sweat left on the hand or surface, and how hard a person touches that surface. But there are several different ways to detect prints, the most common ones being latent fingerprint powders, sonically fuming, chemical developers, and vacuum metal deposition. Latent fingerprint powders is a fairly simple and easy to process. It only contains two things, a pigment and a binder, which when combined, they remove the moisture and residue left from the finger, leaving only the print behind. Common pigments include aluminum, zinc, copper, and colloidal carbon. Common binders include rosin, iron powder, and gum arabic. I found this quote describing latent fingerprint powders. I think it does a good job just in the overall process, from an article titled Latent Print Detection, stating, fingerprint dusting is relatively simple and relies on the adherence of powder to latent print residue to provide good visibility and definition of the fingerprint detail. Latent print powder has an affinity for moisture and preferentially clings to the residue deposited by friction with skin. There are a few drawbacks, such as it can only be done on a few surfaces, and good contact has to be made between the print and the surface. Another way prints are taken is through sonically fuming, which uses nitrogen, carbon, and oxygen and water combined to make the prints visible. Sonically is also commonly known as superglue. When soniclate and water are applied to the surface, it polymerizes, removing all residue, leaving only the print behind, similar to latent print powders. But when the soniclate polymerizes, it appears clear, which powders are then added to make the print visible. And here is the makeup of the soniclate. On the left is just soniclate by itself, and then water is added, creating what there is on the right. Another common way is chemical developers, the most common being nihindrin, which is the most common, and when applied to the surface, it reacts with amino acids left behind from sweat, and it forms an ammonium salt, which lights up as a purple color, making the print visible to be taken. Another common chemical used is 1,2-difluorine, which uses a similar process but lights up when blue lean light is shown upon it. And this method can only be used on paper surfaces. And then here's a couple pictures. On the left is a piece of paper that is being pressed by an iron, and then on the right is the next step where nihindrin is applied. You can see the purple prints left behind. Vacuum metal deposition, or VMD, is the newer and more advanced process, which relies on the use of gold and zinc. But this process can be used on nearly all surfaces, including wood and firearms. Zinc or gold is first applied to lay on the bottom of the print, and then small amounts of zinc are applied, which make the ridges left from the print. And here is an image showing that process right here. You can see the small amounts fall to the bottom, and then it shows creating the ridges left behind. Here in conclusion, the four common ways are latent fingerprint powders, which use a pigment and a binder to remove moisture and residue. Soniclate fuming. Soniclate is polymerized, and then powders are added to make visible. Chemical developers. Nihindrin, the most common chemical, reacts with leftover amino acids from sweat to form ammonium salt. In vacuum metal deposition, uses small amounts of gold and zinc to create the leftover print. And here's the works cited.